My name is Olufonke. I want to talk about chapter 2, question 3, which is the explanation why it is very unlikely to experience excess of water-soluble vitamins compared to fat-soluble vitamin in the context of characteristics of polar and non-polar substances. Example of each soluble vitamins, water-soluble vitamins is vitamin B1, 2, 3, 6, 12, biotin, vitamin C, and folic acid. And fat-soluble vitamins are vitamin A, D, K, which is called ADEK. Water-soluble vitamins are those vitamins that dissolve in water. They are readily absorbed into body tissues for immediate use. They need to be replaced all the time when we eat because they are not stored in the body. Too much of water-soluble vitamins can easily get out of the body through urine, and it is very, very rare to get it to a toxic level. You can build it up in our body up to a toxic level. With that being said, vitamin C may lead to diarrhea if too much of it is taken. Characteristics of polar and non-polar substances. Polar substances are soluble, such as water, because it can dissolve many different kinds of molecules. Unlike non-polar substances, which is insoluble. Oil is insoluble and they are non-polar because they don't interact with water and they are not attracted to molecules. Water-soluble vitamins are polar molecules which dissolve in water and also called hydrophilic because they don't dissolve in water. We can expel water-soluble vitamins out of our body through urine because they are very unlikely to build up to toxic level. If anyone takes too much of water-soluble vitamins, you cannot store it in your body. It's going to get out through urine. Fat-soluble vitamins are non-polar. They do not dissolve in water. They are called hydrophobic, and they are not easily excreted in the urine. So instead, they are absorbed in a disposable tissue where it is possible for them to build up to very toxic level if too much of it is taken over a period of time. Polar molecule experiment. This is like an experiment that shows how polar molecules react to each other, like ethanol and water mixed together, and we can see how the hydrogen bonds between ethanol and water molecules because they are mixed together. And this is another experiment that's talking about non-polar molecule experiments. You can see in the cup we have oil and water and they don't mix. We can see the oil at the top and the water was below, and the hydrogen bonds keep the water from mixing with the non-polar molecules. They don't. It keeps those hydrogen bonds keep the water from mixing with the oil. That's why they are non. That is why oil is non-polar. And this is my citation where I get my information from. Thank you.